Let's continue from where we left off. We have found the first derivation here, and second derivation is to be found by using quotient rule. We should remember the quotient rule, which is u over v whole prime is v u prime minus u v prime divided by v square. We use this rule to find second derivation y double prime, isn't it? There is a negative, keep the negative outside. And now we will use x plus 2y as it is. Differentiate the y, you will get y prime minus keep y, differentiate x is 1, differentiate 2y to y prime divided by x plus 2y whole square. Now simplify this negative inside. So first substitute the y prime from equation number 1. Y prime is given here, so negative x plus 2y times y prime is minus y over x plus 2y minus y into 1 plus 2 times negative y over x plus 2y, close the bracket, and whole divided by x plus 2y whole square. When you simplify this one further, the negative goes inside, so first term will be positive. Multiply everything inside, so when you multiply first two terms, that is xy plus 2y square divided by x plus 2y, and this y is moving inside. You get this negative and this negative will be plus y plus y plus y minus 2y square over x plus 2y whole divided by x plus 2y whole square. In the next step, we will take LCM for the last two terms. This term and this term will take LCM, cross multiply this one here, and then we'll be done. The next page we will do it. What's our y double prime now? Y double prime is equal to we have x plus xy plus 2y square divided by x plus 2y plus y minus 2y square divided by x plus 2y whole divided by x plus 2y whole square. So when you simplify further, this one common divisor will be x plus 2y. So in this first step, yx plus 2y square, when you multiply this one here, yx plus 2y square minus 2y square whole divided by x plus 2y whole square. So when you simplify, your y double prime will be this y square to y square will be cancelled, so you get 2yx plus 2y square divided by x plus 2y whole cube. These two join together. That's the end. Actually, you can stop here. Right, we solved problem number 16, and rest of the problems are practice problem in this case. Next, we will try some solutions have been given for all problems in the PowerPoint, true or false. We have seen the same kind of problem, and you have to tell whether this dy by dx is true or false. You can check yourself. When you differentiate this one, you get 2x plus 2y y prime is equal to 0. When you divide by 2, you will get x plus y prime is 0. So y times y prime is negative x, y prime is negative x over y is true. Use implicit differentiation to find the slope of the tangent line to the curve. So slope of the tangent line is dy by dx, and at the given point x comma y, substitute the values of x comma y given here. Let's try 28. Use implicit differentiation. So first differentiate x by using power rule. 2 over 3 x to the power 2 over 3 negative 1. The same for y. 2 over 3 y to the power 2 over 3 negative 1. Whenever we differentiate y, write y prime. So y prime is dy by dx. So when you find the right answer is constant, it is 0. Now substitute, simplify again. When you divide by 2 by 3, the constant will go off both the sides. By 3 you will get x to the power negative 1 over 3 plus y to the power negative 1 over 3. Y prime is 0. Simplify this one, you get y to the power negative 1 over 3. Y prime is x to the power negative x to the power negative 1 over 3. So y prime is negative x to the power negative 1 by 3 over y to the power negative 1 by 3. When you flip the terms, the powers will be positive. It will be y prime is negative y to the power 1 over 3 divided by x to the power 1 over 3. This is the slope of the tangent. And now substitute the values of x and y. X is negative 1, y is 3 root 3. So you will substitute the values y prime at negative 1 comma 3 root 3 is equal to, there is a negative outside, y is 3 root 3 to the power 1 by 3 divided by x is negative 1 to the power 1 by 3. Negative 1 of the positive root of 1 of the real root of negative 1 is negative 1. So you will get a negative 1 cancelled with the negative. So this is 3 root 3 to the power of 1 by 3. You will get 3 to the power 1 by 3. Root 3 is actually 3 to the power half, again 1 by 3. When you simplify this one, you will get 3 to the power 1 by 3, 3 to the power 1 by 6. When you add the powers, 3 to the power 1 by 2. Try this one. That is square root of 3. That is, when you add the power 1 by 3 plus 1 by 6, which is 2 plus 1 over 6, which is 3 over 6, which is 1 by 2. That is it. The power is 1 by 2. The answer is root 3. That will be the end of this topic. I think it's enough to practice this kind of problems, and then we can find the solutions on the page for other problems. This is question. Find implicit differentiation. Find dx by dy. Find dy by dx and invert it. When you differentiate, it is cosine. No, I mean, just to differentiate d1 into dy by dx, then sin x, it will be cosine x. Therefore dx by dy is equal to 1 over cosine, you will get secant x. That's right. And that will be the end. We can stop here with this kind of problems for this chapter, and then next chapter problem we will discuss. Ignore this topic, okay? This kind of problems. Derivative of logarithmic functions. Some rules are to be recalled here. Some rules of derivatives of logarithmic functions. The first rule, derivation of ln x is equal to 1 over. We don't need to prove this one. We have to remember this rule, and we have already used this one for many problems. Second one, when you get differentiation of log with a different base. See, we know a base change formula. When there is a log b base a, we can write in ln b over ln a. We remember it, isn't it? So when you get log x base b, you can write ln x over ln b. So when you differentiate it with respect to x d by dx, when you differentiate it with respect to dx, ln b is constant. Keep the ln b as constant over ln b. and then derivation of ln x is given here in the first result. It is 1 over x. So 1 over x ln b second result. So you will find the next rule for ln u when there is a chain rule. When you find, instead of x, if you find a function there, you will write ln u 1 over u for derivation of ln, and then differentiate u with respect to x by using chain rule. And the same formula, this formula for u, when with a different base, if you find ln, so it is 1 over u 1 over ln b and 1 over u du by dx, just like this one. Okay, and if it is absolute value of ln absolute value of x, then it is the same rule 1 by x, condition if x is not equal to 0. That's it. Okay, we are going to use these results in exercise set 3.2, problem number 3. Problem number 3, we can solve it by formulas directly. What is it? What is y prime? Differentiate 1 over 1 plus x, and now differentiate 1 plus x. What do you get? 0 plus 1. And the answer for this one is 1 over 1 plus x. Problem number 7. Y is equal to, using the rules of natural logarithm, you can write it as ln x minus ln 1 plus now differentiate. This is 1 over x, this is 1 over 1 plus x square, and then the chain rule differentiate this one, you get 0 plus 2x. So the final answer is 1 over x minus 2x over 1 plus x square. Can stop here. For problem number 8, you can follow the same technique, so I leave it to your practice problem. Problem number 11, you will try. Actually, this is a kind of y is equal to u to the power half. When you differentiate u, first differentiate u, and then with respect to first use power rule, and then actually this is to be integrated by using chain rule. Half u to the power half minus 1, and then du by dx. Where is u? What is u? Where u is ln x. So this is half into u to the power negative half. When you differentiate u, what is du by dx? It is 1 over x, so it is 1 over x here. And now this is half into 1 over u into 1 over x, so u will be 1 over 2 x into 1 over ln x under square root. This is half under square root, so that is it. There are 4 more problems of the same type. Problem number 14, 15, 18 and 26 with the different base problems. Okay, let's try problem number 14. Let's start problem number 14. Y prime is using product rule. Keep x cube, differentiate ln x, it is 1 over x, plus keep ln x, differentiate x cube, it is 3x square. That is it. You can simplify and leave 15. I'm going for problem number 15. Y prime, again product rule. Keep x square and differentiate second term. Whenever we use the formula, what is it? Derivative of log to some base b and x with with respect to x. You should remember the answer. The answer is the answer is 1 over x into 1 ln b. 1 over x into 1 over ln b. That should be remembered. So when you differentiate this term, base is b, so you will get 1 over 3 minus 2x and 1 over ln 2 and then differentiate 3 minus 2 by using chain rule 0 minus 2 plus keep the log 2 3 minus 2x, differentiate this x square, you will get 2x, so simplify it, you will get minus 2x square over ln 2 3 minus 2x. The first part, second part 2x and log 2 3 minus 2x. That is it. I'll solve one problem out of 18 and 26. So we will solve 18 now. Problem number 18 now. Problem number 18. Again, product rule, quotient rule. You should remember u over v prime. V u prime minus u v prime divided by v square. So this is u and this is v. V is 1 plus log base 10 x. If there is no log, then general base, if there is no base for the log, then you take it log 10, log x base 10, isn't it? Differentiate the numerator, which is log base 10. When you differentiate a function which is log x base 10, the answer is 1 over x 1 over ln 10. You should remember this rule and then differentiate log x base 10. So you will get 1 over x 1 over ln 10 minus second part. Second part is keep this log x, differentiate 1, it's 0, again ln 10x will be 1 over x 1 over ln 10 overall divided by 1 plus log base 10 log x whole square. That is, when you simplify, this will be, this is positive and negative log 10x, log x base 10 and 1 over x will be cancelled. When you multiply this one inside, 1 over x 1 over ln 10 plus log 10x divided by x ln 10 minus log x base 10 x ln 10 whole divided by 1 plus log 10 x whole square. Now this term, this is under same term, this and this term will be cancelled. You will get this term divided by this term is your answer. Try 26 yourself. And now we are going to the last category of problems in this case. One of them will be solved right now, the rest is your practice problem. Use basic properties of ln. That is what example 3 from the textbook says. So first 27, use basic property of, so we will take y as the given function, then finally simplify, then first simplify and then differentiate. What is it? ln x minus 1 whole cube x square plus 1 to the power 4, isn't it? Now the product ln of product, this is ln a, there is a rule, ln a b is equal to ln a plus ln b. So we can write ln x minus 1 whole cube plus ln x square plus 1 to the power, and then again power rule of ln 3 ln x minus 1 3 ln x minus 1 plus 4 ln x square plus 1 to the, and there is another rule in logarithm, ln a power n can be written ln n ln a, isn't it? N ln a. That's what we are using here. Now differentiate by prime. What is it? 3 over 1 over x minus 1. When you differentiate x minus 1, you will get to 1. That is 1 minus 0 plus 4 over x square plus 1. When you differentiate this one, you will get 2x. That is it. The answer is home now. So this is 3 over x minus 1 plus 8x over x square plus 1. That's the end. So try in the similar way, try this problem. First simplify, isn't it? Take, I give you some steps, then you try. Take y is equal to ln x minus 1 to the power half divided by x plus 1 to the power half. Now use division rule of ln x minus 1 to the power half minus ln x plus 1 to the power half. Now use this power rule, simplify and then differentiate. This will be half ln x minus 1 minus half ln x plus 1, isn't it? Next step, you can find derivative and can continue this one. The last type of problem is coming up. Whether true or false. Is it true? No, because 2 is constant. When you differentiate ln x, you will get, isn't it? No, actually this is wrong. Actually you should write this one. This is wrong. What is given here? When you differentiate, when it is y is ln x whole square, first use power rule. This chain rule should be used here. 2 times ln x, and differentiation of ln x is 1 over x. This is the answer. So this is wrong. This rule will not work here, right? This actually there is no such rule. You cannot write this one this way. ln x square can be written as 2 ln x. ln x whole square cannot be written as 2 times ln x, isn't it? That's the problem here. That is it. In the last problem is find dy by using the logarithmic differentiation. And solve the problem number 1 or 37. Which one you want? Let's go to 37. You always look for tougher versions. 37. So take ln when using logarithmic differentiation. So this is totally complete. Directly you cannot find. We should introduce natural logarithm. ln y, reduce ln y on both sides. ln. So this will be ln x square minus 8 to the power 1 by 3 x cube plus 1 to the power half under square root, isn't it? Divided by x power 6 minus 7x plus 5. Now by the rules of ln, you will get ln y is equal to ln x square minus 8 to the power 1 by 3 plus ln x cube plus 1 to the power half minus ln x power 6 minus 7x plus 5. One more step, you can remove the powers. 1 by 3 x square minus 8, that is ln, plus 1 by 2 ln x cube plus 1 minus ln x power 6 minus 7x plus 5. Now differentiate. I am writing here at this side. We are solving problem number 37. The second, one more line I can write. So when you differentiate left hand side, it will be 1 over y into y prime. This is 1 by 3 is constant here. ln x square minus 8 when you differentiate x 1 over x square minus 8 into when you differentiate x square it will be 2x and 8 is 0. Next minus, so sorry, this is product, this is positive, okay, minus plus half 1 over x cube plus 1 into 3x square and minus differentiate this one 1 over x power 6 minus 7x plus 5 when you differentiate this inner term 6x over 5 minus 7, that is it. Now simplify here. In the left hand side we want only y prime, so keep the y in the right side. Now write all the terms available here. 2x over 3 into x square minus 8 plus 3x square divided by 2 into x cube plus 1 minus 6x power 5 minus 7 divided by x power 6 minus 7x plus 5. In the last step, close the bracket here. We have to replace the value of y from the given equation. So when you write this value of y here, that's it. That's the end of the problem. That's it. We can stop here for this topic. No more problems necessary. Stop. Last problem is 37. You can stop here. No need to find the tangent line of any graph. You can stop. Oh, I think one more problem. I think there is one more problem which is important. So finding. Okay, what is it when the base change formula for the base is the variable, isn't it? That's it. So base change formula should be remembered. What is it? ln ln a base b is ln a over, sorry, logarithm of a base b is ln a over ln b. This formula will be used here. So logarithm of e base x is ln e over ln x. So when you differentiate logarithm of e base x, you will find ln e is 1. You are differentiating 1 over ln x. You take u is equal to ln x. Therefore you are doing d by dx of 1 over u. You will write this 1 minus 1 over u square into du by dx, which is minus 1 over ln x whole square. When you differentiate ln x, it will be du by dx is 1 over x. So this will be 1 over x. So the answer is here for case A. In the similar way, you can try B. That's it. Problem 39 we can start with. Thank you very much. If you have any doubts, you can send mails or ask in the comments or contact through Blackboard. Thank you very much.